Welcome. In this video I'm going to show you how you can use my stikpetE add-in for Excel and to analyze then a single binary variable. The add-in can actually be installed from my GitHub. You can download the XLAM file there and then you can simply do the installation as for any other add-in. For documentation, currently I have a link here to my Python documentation, but the functions for Excel work very similar. In the future I might change this. I'll leave a link to this file in the description below. The overview for what we're going to do is we're first going to create a frequency table to get an impression of the data, then perform a statistical test, and then do the effect size measure. I'll also quickly show you some alternative tests and some alternative effect sizes. Let's get started. I have in here my data stored first as text and second time around as numbers. So you can see it's the same data, just one is numeric and the other one is text. To get a quick impression, I made a frequency function. You can see it work here. It's actually an array function. In previous versions of Excel, you then had to use Ctrl-Shift-Enter to actually get the full table. As you might notice here, it nicely shows now the frequencies, the percent and the valid percent. These two are different because this one excludes any missing values. So there were some people, like over here, that didn't give an answer. The cumulative percents we can ignore. So it seems that there were more males than females, but is this actually also significantly more? So we would expect 50-50, so the same for each. So 50% as it were. We can run a binomial test for that, so I've made a function for that. As you can see here, it's simply taking the data. And that's one thing to be careful for with all of my functions. You have to specify the range, so you can't use the entire column A. So I really had to select A2 all the way up to A55. So don't use column A as in A double dot A, just use the specific range. In this case it's below 0.05, which is the usual threshold, so we would then reject the assumption that they would be equal in the population, so we indeed have significantly more males than females. We might actually also report an effect size measure. One that's quite straightforward is Cohen's G. Cohen's G is available as a function, ES for effect sizes, Cohen G, and again the range, and it will give you minus 0.24. I can then use my rule of thumb, or actually from Cohen in this case. I also have a function for that available, and it will classify this one as medium. This is then based on rules of thumb by Cohen. So that's how this could actually go in one go. I've done the exact same again, but then using the numeric field. So I have a 1 for female and a 2 for male. And I can simply then actually use those. So I'm now using, as you can see, column B, or not the entire column, of course, just B2 till B. Not sure why it's going to 55. Oh yeah, because that's the last one. And then I actually also give it the codes. The first ones are the numbers that were used, and then their textual equivalent. So that gives you then the exact same table. We then can also simply use the binomial test on the numeric data, as you can see here. And we can also do the Cohen's G on the numeric data, and it also gives the same results. Alternative test could be a score test, which is using a normal distribution. I have the same data available, and again you can simply use score OS. This will actually give you a statistic value, the p-value again, and this is using a normal approximation. And we can also do the same for the numeric data. The wall test, very similar to a score test, as you can see. Similar results. Again, they're all below 0.05, so none of them actually gives different results. Alternative effect sizes, besides Cohen G, you can use a Cohen H for a one sample. So there's a function, of course, made for that. It requires the codes that we're using, and I'm also saying, well, I just want you to use female and male. I could have actually left that out. I can also use the numeric scores, and that will give us the same result. Now, in order for a rule of thumb for Cohen H for one sample, we actually first need to convert it to a regular Cohen H. So I have an ES convert function available there, and just tell it to convert from Cohen H one sample to a regular Cohen H. Then I can use the rule of thumbs for Cohen H, and in the end that gives us again the medium classification. There's also something known as an alternative ratio, sometimes referred to as a relative risk. There are two, one for each category. It's in essence how far off one would be if they would both be 50%, and this is how far that's off then. So 1 minus 0.52 would give you 1.47, and the 1.47 minus 1 gives you also 47. If you've used that score or wall test, you could also use a Rosenthal correlation coefficient, and that's also available. That actually requires some test results, so the statistic then of that score or WALT and the sample size, which is luckily available in the output. Alright, and that's how you can quickly analyze a single binary variable using my stikpetE library. Hope this was helpful, and thank you for watching.